So let's just jump right in. We are building these absolutely incredible AI models, right? They can write poetry, they can write code, they can even create images that look totally real. But there's this one huge problem. They are so unpredictable, they're uncontrollable, and sometimes they just go completely off the rails. It's kind of like having a brilliant actor who just decides to improvise in the middle of a live show.
And that really brings us to the biggest question hanging over all of AI right now. How do you actually control these things? How do you guide what they're doing in real time without having to spend a fortune and weeks, if not months, retraining the entire thing from scratch? It's a massive challenge. To really get why the new method we're going to talk about is such a breakthrough, you first have to understand where things are at right now with AI control. And, it's a pretty tough spot. At the moment, we've really only got two main ways to do this. First, you've got fine-tuning. This is the slow, super expensive option. It's like sending that brilliant actor back to Juilliard for a whole year just to learn a slightly different role. Then you have prompting. This is fast, yeah, but it's just not reliable. It's like shoving a new script in the actor's hands right before the curtain goes up and just hoping they get it right. Sometimes it works, but a lot of the time, it's a total mess.
Now, what's so fascinating here is this idea from the research paper called elicitation overhang. Basically, it's the gap between what the AI model is capable of knowing and what we can actually get it to show us. The model might secretly have the ability to be more honest, or way more creative, or a lot less toxic. But we just don't have the right words to ask for it. All that potential is just locked away inside.
So to get to that hidden potential, you can't just talk at the model from the outside. You have to go inside its virtual brain while it's actually processing information. And that's where this incredible new technique comes into play. An AI doesn't think like you and I do. Its thoughts are these massive, complicated patterns of signals called activations. When you give it a prompt, these activations light up and flow through all the layers of its neural network. You can think of it like the internal language the model uses to understand what you've just asked it to do. And this is the light bulb moment. The researchers basically said, hey, what if we could reach in and tweak those signals as they're happening? This quote from the paper gets right to the heart of their idea, which they call activation engineering. It's all about directly editing those internal signals while the AI is generating an answer, all without ever changing the core model.
Now, I know what you're thinking. Reaching into an AI's brain and messing with its thoughts sounds incredibly complicated, like something out of science fiction. But the method they came up with, it's called ACT-AD for activation addition, is actually beautiful in its simplicity. And the best way to get it is with a pretty simple analogy.
I want you to picture a giant sound mixing board, like in a recording studio, but instead of faders for guitars and drums and vocals, you have faders for different concepts. A fader for love, a fader for hate, one for truthfulness, maybe even a fader for talking about weddings. Activation engineering is all about figuring out how to find those faders and move them up and down. So how do you actually build one of these faders? It's a surprisingly simple recipe. First, you feed the model a positive word, like love, and you just record the pattern of internal activations it creates. Then, you do the exact same thing for a negative word, like hate. Step 3, you just subtract the hate activation pattern from the love activation pattern. And what's left over? That difference is what they call a steering vector. You've done it. You've isolated the pure signal for that concept. You just made the love fader for your mixing board. And here is where the magic happens. You can take that love steering vector you just created and add it to the activations of any other prompt you give the AI. You can literally reach in and turn up the love on whatever thought the model is having, steering its final output in real time. Okay, so it's a really cool idea, a sound mixer for an AI's brain. But does it actually work? Well, let me tell you, the results are pretty amazing. So check this out. They give the model the prompt, I hate you because. Now, with no steering, it completes it with something nasty. But then they add that love minus hate vector we just talked about, and the model's output completely flips. It turns a sentence that started with hate into a confession of love. It is the exact same model, the exact same prompt. The only thing that changed was that tiny little nudge to its internal thoughts. And this isn't just some lucky fluke. The data shows this works over and over again. When they tried to flip negative sentences to positive ones, the normal Llama 3 model got it right about 42% of the time. But with ACT-AD turned on, that success rate jumped to almost 67%. I mean, that is a huge leap in just being able to rely on the model. And it's not just about feelings either. This is massive for safety. They tested this for reducing toxicity in AI-generated text. Turns out, ACT-AD was able to make the OPT model 8% less toxic than the next best method. That's a really big step towards making these AIs safer for all of us to use. Now, you're probably thinking, okay, if you're doing this kind of brain surgery, does it cause other problems? Does it mess up the AI's ability to do other things? Well, it looks like the answer is no. The researchers threw almost 30,000 factual questions at it, and they found that adding these steering vectors had almost zero impact on its general knowledge. You can steer its personality without making it dumber. So this is way more than just a cool science experiment. This has some serious real-world value for anybody who's trying to build products using AI.
Think about what this means for a business. First off, you get to skip that expensive, time-consuming retraining. You can put in safety controls that work in real time to detoxify outputs. Your marketing team can make sure that every single piece of copy the AI writes is perfectly on brand. You just get a more reliable, more consistent product. And maybe the best part? It's fast, like really fast. The researchers said they could find and test brand new steering vectors in just a couple of minutes. Not weeks, minutes.
So this all brings us to one last thought. This technique basically gives us a control panel for an AI's mind. And that leaves us with a really big question. If you could add just one fader to that panel, what would you choose? Would you crank up the truthfulness fader to fight fake news? Or would you turn up creativity to solve the world's biggest problems? Or maybe you'd install a fader for something like ethical reasoning. The possibilities here are just as huge as the AI's mind itself.